SVM is basically to divide the data set into different groups of data.
Question. Yes. Can I ask a question?
No. yeah, sure.
No,
And okay, so suppose given a data set, each belongs to one of two classes of data, and then the goal here is to decide which class a new data point will be in. And here are some pros and cons of SVM. First of all, it's very effective, and especially in the high dimensional spaces. And then because we are using the training points, so it's a very memory saving method. And also it can be very multifunctional because there are different types of kernels we can use to do the decision making process. And the disadvantage will be when the number of features is much greater than the data size, the SVM method may be underperformed. And here are two classification samples. The first one on the left side is we use the linear kernel, and then you can see there are three straight lines to divide the data set. And then on the other side, the only difference between them is we use curves instead of straight lines to divide the data set. And the method of SVM can be extended to solve regression problems. And this is so-called the SVR, the support vector regression method. And then they are both linear SVR and also nonlinear SVR.
So good evening, everyone. So for the purpose of our project, what we did is we kind of explained a little bit about linear regression. We did SVR regression. And the purpose of that was to create like a comparison between both. So here what we have is the plot of one of our codes. We have here that the SVR, the weight of each feature, reflects the feature's true contribution. And the linear is where big weights will be allocated to the feature which is best correlated to the dependent variable. Okay, again, here we went ahead and we just we wanted to highlight the difference between using linear and nonlinear kernels. The linear SVR establishes a direct relationship between a dependent variable and the independent, whereas the nonlinear tries to map data into a higher dimensional space. So why we go ahead and do this, we went ahead and we looked into the materials that you referenced. And we saw the example that they provided on the SVR quantopian algorithm. It's very complex. It has a lot of components, but mainly where this is applied is in the regression, in the specific regression forecast that is used to predict the stock price for the opening stock price. In this case, it was for SPY. So what we did for our project is we created a smaller version of stock price predictor. We did it for SPY, and we used historical data for the stock for the month of April. And we went ahead and did it for, we did it with the RBF model and the linear model and the polynomial model. And for this, we came out with that the predicted opening price for today, April 25th, would be 233 with the RBF kernel, 234 with the linear kernel, and 233 with 89 using the polynomial kernel. And we included the plot for everybody to see the difference between these types of kernels. That's basically the means of our project.
Good job, please.